Okay, welcome back. We are going to continue to look at the domain and range and list it out. We're going to do this first for a mapping, and then we're going to do it for a set of points. So for our domain, it's our x values and our y values. It might help to do that across the top. And remember, our x values cannot repeat. So I can't see, when we look at a mapping, we don't want to see two arrows coming from one x. So only one arrow from each x value. So if we see a double arrow coming out of an x, that's not going to work for us. So the first thing we're going to do is our domain. So we're going to list out the numbers from smallest to largest. We have a -8 that is technically our largest number, or I'm sorry, our smallest number since it's a negative. And then from there we go up to 1, then 3, then 4. And then for our range, we look at those y values, 5, then 6, then 7, then 8. Now, we still have to determine, is this a function? Well, I see 2 arrows coming out of that 4 in the x's. That does not work, so this is not a function, unfortunately. Now, I want you to do example 4 on your own in class, and then let's look at with a set of points. So we're going to find the domain and range of example 5. We're going to do the same thing. We're going to look at all the x values and then all the y values. So I'm going to put a little x across the top. Remember, your x is the first number in each coordinate pair. And then the y's are the last number. I'm going to underline the y's so that they stand out. They're a little different looking. Again, we don't want any repeating values in the x's. No repeating x's. So we've got 2, -1, 3, and 4. We're going to put these in, again, least to greatest, smallest number first, which is -1. And then we have 2, 3, and 4. And again, no repeating x values. Very important. Now for the y's, we're going to look at those, and we have -4, -1, and 5. Now your y's are allowed to repeat. That's okay. That's not the end of the world. You can have a repeating y, you just cannot have a repeating x. So repeating y's are okay. So if this is a function, we have no repeating x's. So yes, this is a function. All right. I want you to work on example 6 yourself. And then I'm going to go ahead and jump to example 7, which is a graph. We're going to check to see if this is a function. We're also going to do the domain and range. So our x values are the numbers across the bottom. Your y values are the numbers across the top. So looking at the domain, we're going to start at the farthest left side of our graph and work our way over because our smallest numbers are on the left-hand side of the graph. So looking through, we have a point at 1, a point at 2, a point at 3, 4, 5, and 6 for our domain. So our domain has all the numbers 1 through 6. For our range, we're going to look at from bottom to top. We're going to travel up the graph to see where those points hit for our range, which again is our y values, and that domain is our x value. So starting towards the bottom, the first one we hit is -1. And then we hit 0, +1, +2, +3, and then all the way at the top, we have a 6. Okay, so a little bit different, the x and y values from a graph. That can be hard for some people if they forget which part is the x and y value. I always make sure I have mine written down or circle it or highlight it in a different color on the graph itself. Now we want to look and see if this is a function. Again, do we have any x's? With a graph, you could always do a vertical line test. You can also just, again, look at that domain. Do you have anything repeating? Or did we have any numbers that went to more than one spot? If I do a vertical line test, 1, 5, 6. None of those have a second dot, so we are all good there. So that is, yes, a function. So work on example 8 and example 6 on your own, and we will start with 1.2 day 1, or sorry, 1.3 day 1 tomorrow. Thanks, guys.